So as a 30-second recap, here is our flowchart for the IndexOf loop. Go ahead and pause it and stare at it. What we do is we keep searching the string until we find the character that we want, starting at position 0 and going as long as the position is less than the max. But if we ever find it, found at becomes set to our current index position, and that makes this condition false, and we will fall through the end of the while loop and return our value. And here's the code to match. So you can pause that if you need to, and it will also be in the notes. And here's how we called it. It turns out that the string method, the string class already has an IndexOf method. So practically speaking, we didn't have to code that, as is the case for a lot of the common things that you do. They've been coded in the past. If we wanted to do it with the string method, we would just do this. I is equal to s dot index of t. That's a shortcut for it. That searches the s string for the first occurrence of t. Or if you want to find the last occurrence of t, if you want to start at the end and search the other way, you can do I is equal to s dot last index of t. And there are variants of IndexOf. The Java's IndexOf function is more powerful than ours because it also supports searching for an entire string within the string. And ours isn't nearly that sophisticated. It'd have to be a more complicated loop. Because once you find the first character that matches, you would then have to keep going, to see if you'd found the second one or not. So it's more complicated. So IndexOf also supports, come back, a version where you can specify a starting position. If you want to ignore the first 10 characters, then you start at index value 10, and it would go that way. So sometimes as you're processing, you want to find all of the i's in a string, or all the periods, or all the somethings. And so you might need to make use of the ability to start at a specific index.
Question about NetBeans in general.
Yeah.
So, it's got those pretty helpful IntelliSense guides. When you come back to something, you may not, recognize what each of the kind of arguments for each function are.
Right.
Is there a way that NetBeans will redisplay that?
Right. So since, like if I wanted to do index of t starting at position 2, and I didn't remember what those were,
right,
I could highlight that and hit F1 or right-click and do Show Java Doc. Oh, it's not F1, it's Alt F1. But anyways, right-click and do Show Java Doc. It's not going to pop them up in the little thing, but you'll see the entire documentation for the method.
I've been pressing F1 and not getting any.
I was thinking it was F1. It ought to be. Isn't that what it is in Visual Studio?
That's what it is in almost everything.
Yeah. Okay. So anyways, it should have done that. Okay. So let's make a better string. String is equal to rows state is really awesome. And we want to write a loop that will print out the index value of every E in it. So I think in this case I am going to make it a while true loop and use a break statement. So let's look for the first occurrence of an E. S is equal to, I need a variable to indicate the last time it was found. So I'm going to declare a new counter, and I can't think of a good thing to call it, so I'm just going to call it X because that's a really bad name for a variable. Maybe I'll call it last, but that makes it sound like the, okay, yeah. Here we go. So this is our starting position. We're going to start searching the string at position 0. So I is equal to s dot index of, and we want to find every E. We want to find the first E, but starting at position 0. Nope, starting at position last. If I is less than 0, or if I is equal to -1, we didn't find a darn thing and we want to break. But if we did find something, good news. Now we can print that out, system.out.println E found at plus I. And then we can set our last position equal to I. Okay, so I'm going to go back and I'm going to make 2 changes to this. But whenever I go back and start editing stuff I've always typed, it leaves some people behind. So please to make a note. We are going to set last equal to -1, and I had a nagging feeling I was going to do that. Go make that change, please. Last is equal to -1. And then when we do index of, we're going to make it last plus 1. So we start at 0, but then if we find E at position 6, we're going to start searching the string at 7. And then if we find E at position 23, then we're going to keep searching from position 24. And just to make sure this works correctly, I'm going to stick in 2 E's into my string in a row, just because I want to see, make sure that it doesn't accidentally skip one of them. Nope, it found it at 3, 4, 10, 16, and 24. If you didn't add the double E on yours, your numbers will be different. Okay. So this is indicating a different way to use the while, but I know we've talked about using break before. Flowcharting it is a little bit unusual, or it makes language constructs like this are newer than flowcharting. You know, flowcharting has existed since before the invention of electronic computers. So if you were going to flowchart something with a break statement, and if I do this, I'm going to tab off of it. Is everybody done typing? If not, that's okay. You doing okay? You got yours typed in? Okay, cool. So a loop with a break looks like this. Do some setup maybe, but what's most important is that you just put, and it doesn't have to be while true. You can break out, we could have broken out of our index of loop. We could have written that to use a break, and as a matter of fact, why don't I just copy our index of loop and then modify it to use a break statement. So my while condition can be simpler because I'm going to trust the break to get us out early. And then down here, after I have found it, I would issue a break. And to me, it ought to be in a different symbol than just a square, but I haven't ever found anybody indicate how that should be flowcharted. And so, when you hit a break, it looks like it ought to hook back up to there, but in reality, it goes all the way to there. And that's a nasty flowchart at this point. There. You see what I mean? As soon as we hit our break, we exited the while loop completely. And so it kind of breaks our rules of an if statement having 2 branches that hook back up together. But that's the way it works. Conceptually, it's really clear to see how it works. But then if you try to justify it with the rules of flowcharting, then it starts looking ugly. In my opinion. Maybe you think it's a work of art. I will hang it on my fridge. All right, we are actually done with Chapter 4. I don't see anything in there that we haven't covered already. So we're going to go to Chapter 5. Using pre-built methods. The string method has a lot of different methods. We've already used I know, char at. Have we done index of and substring? Well, I mean, obviously we just did index of. Have we done substring? I'm not seeing a lot of shaking head yeses. Okay. So API. application programming interface. When you write a complex system, what you're going to wind up doing is dividing your code up into classes, and then each class will have a set of functions, a set of methods that can be called by your program. Well, you can write up the documentation for that and publish it, internally for your company or whatever, and that is the application programming interface. That is how somebody works with your code. So if somebody else is going to borrow your code and modify it, or use it in order to do something, in an API, typically, or not typically, but could involve like a graphics library, draw something at X, Y, or it could be controlling a device. All of our APIs inside of Java that we're dealing with here are a little bit more mundane than that. We have a scanner class API, and so the scanner has methods like .next and .nextInt, next double. Those are the API, but I'm going to stop using API. Those are the methods of the scanner class. Then there's the math class. Math calculations are sometimes rather complicated. We don't want to have to write a sine or a cosine or a tangent formula ourselves. We could do so, but we don't want to have to do that. Just like we don't want to have to calculate pi ourselves. And again, there's an algorithm that calculates pi, but writing it is kind of nasty. We would just rather use pi that's built into the math library. So if you're going to use the math class, most classes that you bring in, you have to add an import for. I believe the math class in Java is an exception. I believe if we go to our code and down here we type double D is equal to math.pow 10 to the power of 3. Yeah, I did not have to go up to the top and add an import. The math class is one of the few things that is brought into Java automatically just to make programming easier. And in some languages like C and Python, that's not true. You actually have to import math classes in order to get the power of them. So POW is a method that's inside the math class. It takes two values, one value being the value itself and the next one being the exponent. So this is 10 to the power of 3. There are other ones. There's the absolute value, math.abs. What's the absolute value of negative 10? Well, it's going to be 10. What's the absolute value of, what is 10 to the power of 3? It's 1,000. There are min and max functions. Math.min, which one of these values is smaller? 1 divided by 3 or 1 divided by 4? Let's make these 1.0 so they'll actually be doubles rather than floating points. 1 divided by 5. After we run this, which one should be smaller? Yeah, 1 divided by 5 is smaller than 1 divided by 3. So when I run this out, it should say 0.2. Then max works about the same way. D is equal to math.max, which is larger, 1 or 2. It's going to print 2, or it would if I tried to print it out. If we just type math and dot, we will see, as you were noting, all sorts of things. There are absolute value functions for doubles, floats, ints, and longs, so that kind of fluffs up the length of the list. Add exact, well, that's interesting. That's kind of implying that the rest of our addition isn't exact.
Yeah, I wonder what the basis of precision is then.
It returns the sum of its arguments, throwing an exception if the result overflows. I guess that's its key. Normally adding might not generate an exception. I guess we could find out. Let's add two numbers. Int b is equal to 2 billion, 1, 2, 3, 4, 5, 6, 7, 8, 9, plus 2 billion, 1, 2, 3, 4, 5, 6, 7, 8, 9. System.out.println b. Now there's no way that the compiler can know that this is not going to work. that would be expecting too much to know that that was going to be overflow, that we were going to exceed the capacity. And so it didn't flag that as being bad, and then when it ran, we got some garbage results. So that add exact would have generated an error, an exception to catch. B is equal to math dot add exact, and I could add those two numbers, 2 billion, 1, 2, 3, 4, 5, 6, 7, 8, 9, and another 2 billion. I should have stored that in a variable. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. That should actually blow up. So it blows up. So there is a reason for that function. What do you know? I hadn't noticed that before. Math dot pi is in there. D is equal to math dot pi. There's also E. There are log functions. Log base 10. Log base 1p. I'm not sure what that would be. I could learn so much just by looking at this. So natural logarithm of the argument and 1. Okay, anyways, all sorts of different math functions. Oh, floor and ceiling. The floor of 3.9 is 3. It rounds it down. Floor just means round it down if it's not a non-even number, kind of like the integers do. Ceiling means round up. If I could spell ceiling, it would help. There we go. So 3.9 rounded up would go to 4. Oh, it was just seal and not ceiling, excuse me.
Does that return an int, or does it keep it as a...
I'm sorry, pardon me?
Does it return an int, or does it keep it as a decimal?
Good question. Let's find out what it returns. D is equal to math dot ceiling. Why are you not popping it up? Okay. It's returning a double, interestingly enough. There's no reason for it to, in my opinion. And then there's a round function, which obeys the rule that if it's, 3.5 and above, it rounds up, and 3.49999 and below, it rounds down. So D is equal to math dot round. If we round that, it should be a 4. Let's run it and make sure. I'm always curious to find out whether a library rounds 3.5 up or down, so I'm going to run this 2 times. All right, rounding 3.6 did get a 4 as I expected. How about 3.5? That's a 4 as well. How about 3.49999? Okay. Wait.
What?
What? Huh. Apparently I just added too many 9s to it. Alt F1. Round. Returns the long closest to the argument with ties rounding to positive infinity. It doesn't really explain. Okay, anyways, like I said, I'm always curious to see how it handles things around. I wonder at which point it decides to round that one up. That'd be a question to ask Stack Overflow.
So what's
The number of 9s is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then we have 16 and 17. What is the precision of a double in Java? How many characters does it support? So a double is 64 bytes, where 52 of them are used for the mantissa, which is the number that's not the exponent, and then 11 bits are used for the exponent, and then 1 bit is used for the sign. So anywhere between 15 and 17 decimal digits is supported in a double, and we're kind of up against that level. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We're asking it to do a calculation with 17 digits of precision, and that may be just a little bit too long, and so it went ahead and rounded it up before it did anything. What would happen if I stored that in a variable and then printed it out? Sorry to go off on this tangent. Maybe this is useful for y'all, or maybe you're playing Candy Crush. Let's go look. Yeah, check it out. Just when I declared that as a constant, it went ahead and rounded it up to 3.5 because I had exceeded the precision. So that makes sense.
You familiar with bankers rounding?
No.
It's what Microsoft Access does, even though Microsoft Excel doesn't.
Oh, yeah?
And so like 0.125 will be rounded to 0.12, whereas 0.135 will be rounded to 0.14.
No.
The
Why?
5 determines which way it's going to go up or down based on the number in front of it, odd or even.
That's
It's
bad.
Terribly obnoxious.
That's obnoxious.
It might be the reverse of that, but it's.
But yeah, I get the idea. That is crazy. So to use a method, you need to know what type of data to pass it, what arguments to pass into it, and then what it returns. All of these functions that we've used so far have accepted doubles and returned doubles. But they also can accept ints. But an int will be converted on a fly to a double, and that kind of conversion is acceptable when you're going from a lower precision, smaller format to a larger one. So you could pass an int to it, a long to it, a float to it, and it'll handle all of those, converting it to a double. So we don't really have to worry about whether we're feeding the math.floor function integers or floats or whatever. They all get upgraded. They all get promoted to doubles on the way in, and then a return of a double. So to write our function, public means that it's accessible outside the class so that it could be used inside another class. And then that's the return type. And then you give the function a name, the method a name, and in between the parentheses you list the parameters. Here they're calling them arguments. The terms are very similar, but they have different meanings. Parameters are what they are called when you're inside the function, and arguments are the data that is passed to it. So if we go back to our IndexOf code, here, S and T are parameters. The parameters are the variables that live within the scope of this function. Then the arguments, that is an argument, and that is an argument. Even though they happen to have the same name, they're conceptually different things, because the arguments could be constants. We could look for, you know, the occurrence of the first O in wow or whatever. So the arguments fill the parameters. And the textbooks don't always make that distinction clear, and I sometimes fumble them when I'm talking about them. But if I'm saying it correctly, I'm calling it an argument when I'm looking at the function call, and I'm calling it a parameter when I'm inside editing the function. So the math class, ABS, absolute value. Max, there's another one. Here they wrote 2 versions of max. And the reason they did that is because sometimes you would want to get an int out of it, and sometimes you would want to get a double out of it. Now in my mind, you could just cast the result to an int if you wanted an int out of it, but they went ahead and provided 2 versions. Why would not one version be enough? You know, here I was bragging about how things will get converted to a double if that's what the parameter takes. Well, I'm not going to even explain. When we talk about method overloading, it will make sense. Okay, and then there's a minimum function, and then there's a power of function. And then there's the random. Random returns a number between 0 and 1.0, not including 1.0. Then you have to convert that. If you're going to use this random number generator, there are other ways of doing it in Java. You have to do something to convert it to the range that you want. So if you're mimicking a Yahtzee and you want to roll a 6-sided die, you would have to change this value so that it no longer was a range of 0 and 1 or 0 and 0.9999999, but 1 to 6. There's a better class for doing that. It's easier to use, so I'm not going to talk about that one too much. Then there's round. Oh, why did I forget square root? Probably because you could use the POW function to get the square root. These two things do the same thing. D is equal to math.pow. I want the square root of 2, so I'm going to raise 2 to the power of 0.5. That gets the square root of it. 2 to 1/2 is the square root. Then D is equal to math.sqrt2. That syntax is certainly cleaner. If you have a language that supports an exponent character, like if you could type this 2 to the power of 3 and actually have the language support it, then that's a sneaky quick way of getting square root without even knowing what the square root function is called, is to take 2 to the power of 1/2. Java doesn't have an exponent character. C, I believe, does not either. Python does. It's asterisk asterisk. That means 2 to the power of 1/2, which is the square root. So if you wanted to get the cube root of something, you math gurus may correct me, but the cube root of 2, I believe, could be calculated like this. Is that not correct? Take something to the power of 1/3. And so let's see if that works. The cube root of 27 is 3. System.out.println D, just because I want to see. Hopefully that's 3 when it's done. Yeah, okay. Horton's law says that the length of a river is related to the area drained by the river. So if you know the square miles of a river that it covers, that it drains, you can supposedly calculate the length of it. That's interesting. It's to the power of 0.6. Alright, I'm not seeing anything else in here that we really need to explain. The wrapper class. The wrapper class are the same versions, or excuse me, they're named similarly to the primitive data types, but they start with a capital letter. And if they don't think that it's a whole word, they go ahead and make it a whole word. So the wrapper class for char is character. The wrapper class for integer, for int, is integer. These give extra functionality that these do not have. In some languages, every data type is a class and comes with functions attached to it. C# is that way. However, in C++ and in Java, you have primitive data types, which are just numeric values. And then you have classes. And the classes give extra abilities, such as, say we have a string, 3.9, and we want to convert that to a double. Somebody has typed in 3.9, and we weren't lucky enough to have a scanner.next double in order to do the conversion for us, but we can do that conversion. D is equal to double dot, and double in that case was spelled with a capital D, parse double, parentheses S. That attempts to do the conversion, and it throws an exception if there's something wrong with it, like if there was a letter in it. That could not be converted into a double because it's not a proper number. So this is an example of using the wrapper class. You could give values to elements in the wrapper class. We could say that, oh, by the way, that's a DD. I mean, that's a double. Usually you don't have to do that, but there are some data structures which require the data to be stored in them to be enclosed in wrapper classes rather than primitive data types. And if you take advanced Java, which I hope all of y'all do, then you'll come across that concept. I'm not sure we're going to hit it before then. Let's see what else the wrapper class supports. DD dot, suppose you have something stored in a double. Not too many of these are real interesting. I'm not seeing anything there. Okay, but double dot, we see all sorts of interesting things. The maximum value that a double can support. The minimum value that a double can support. The maximum exponent. The minimum exponent. We can find out all sorts of information by querying the double wrapper class. Size, I guess, would just be the number of ints. Since it's a 64-bit data type, I would hope that its size would return 8. Then there's these other things. Parse double. Turn it into a hex string. Just turn it into a plain string. Let's do that. Now that we have something stored in D, let's turn it into a plain string. S is equal to double dot I've already forgot what those were called. Two hex string and two string. Okay, so double dot two string and pass in the number D. That converts our double back in to being a string, so that you could send it down the internet or into some API that required a string rather than a numeric value. There's a faster way, a cheaty way of converting something to a string. This does it as well. That's kind of goofy looking to non-Java programmers, but all this is saying is take an empty string and then concatenate it to whatever follows it. So D gets converted to a string, just like we've seen when we did our prints, and you added something, you printed two strings, or you printed a string and then a number, it gets converted to another string. So that's a fast way of converting it to a string, and when I say fast, I mean in the shortest number of characters. It's not any faster for the computer. And here's the more proper way of doing it. And I really just do that all the time, because once you see that and get used to it, yeah. But that looks better. Okay, so S is equal to double dot two hex string. I'll be real curious to see what the hex string for 0.33 is. So I'm going to print that out. Huh, what do you know? Check that out. There's a P there. I've never done this before. I've never tried to get a hexadecimal string of a double. But I know that that P has to mean...
E, when you're base 10, is it an E there?
Yeah, so it would be an E if it's base 10, so P if it's an exponent in base 16.
Yes, E could be an actual digit.
So that's interesting. Let's do another value, like just 333. Now I'm going to do them both. These should be the same except for the exponent, but that's in base 10. In base 16 they may look completely different. Yeah. Wow, that went from a P of -2 to a P of +8. That confuses me completely. I'll have to find out what that does. Alright guys, let's stop our lecture here. And if y'all would be so kind as to do these instructor evaluation, but I'm going to have to ask for a teacher's pet to take it downstairs and slip it under the door of the office. So, who knows where the office is and is willing to do that once class is over? I'm going to
Which
pick
office?
someone. Pardon me?
Which office?
Just someone downstairs.
Okay.
Alrighty. Yeah, the office is the where the secretaries and the admin people sit down there. So, my name is Jeffrey Thompson. This is CIT 1613. Intro to Java. Our class number is 7684, and the rest of it you can figure out because you know what year and semester this is.
That's a lot of responsibility.
All right, and I brought pencils. Anybody needs one? So the way this works is you just fill it out and then you say good things about me, so I'll get a raise. No, I'm kidding.
There you go.
Give me an honest
Oh, does it need to
evaluation.
be a pencil?
Yes.
All right, I actually have a pencil too, so we're good. Wait. No, that's a higher pressure gauge, thank you.
You're trying to write it out.
I don't think it worked very well.
And I'm not allowed to be in here while you're doing that in case I unfairly intimidate you or something like that. So I will step out into the hall. And this is it. Once you do that, then class is over, and I will see you all on Tuesday.
Fantastic, have a good weekend.
Oh, you too.